All right, IB AI SL2. Today we're going to continue our work with probability distributions, but today we're going to talk about expected values. So before we get to the definition of an expected value, we're going to start with this example. They tell us that the probability distribution of a discrete random variable u is defined by this right here, which means if you plug in different values for u, you find the probability of each of them. We're going to find the value of k and hence draw the table of probability distribution. So first, all the possible things that u can be are 4, 5, 6, and 7. So u can be 4, 5, 6, and 7. That's it. Now the probability of each u, capital U and little u, is plugging those numbers into the formula. So if you put P of 4 into it, you get K 4 minus 3, 8 minus 4. So that becomes 1 times 4, which is K, times K, which is 4K. So 4K is the probability. If you do the same thing, if you plug 5 into P, into all those spots, so if you do K times 5 minus 3 times 8 minus 5, I believe this will be 6K. If you plug 6 in, you should get another 6K, and then if you plug 7 in, you get another 4K. Now, you might be looking at that and thinking, well, I have no idea what K could be. It could be any number. Let's not forget that all of these in any sample space have to add up to 1. So we can figure out what K is by doing 4K plus 6K plus 6K plus 4K is equal to 1. If you add those up, I believe this is 20K equal to 1, so K is equal to 1/20th. That means if we're to redo that table with K equal to 1/20th, that we can find the actual probabilities of these events. And they will be, if you put 1/20th in right there for K, 4 over 20 is 1 over 5. And then if you plug it in with 6 over 20 is 3 over 10. And then 6 over 20 is 3 over 10. And then 4 over 20 is 1/5. So those are the actual probability distributions of u. Now, part B says, in 100 trials, calculate the expected value of each possible outcome of u. If we're going to do 100 trials, that means we just have to take each of these numbers, their probabilities, and multiply by 100 to find their expected values. This just means if you were to do 100 trials total of picking these 4s, 5s, 6s, and 7s, each of these would be the number of expected times you would pick those numbers. So we'll do another one for the 100 trials, where this is u. And then this is not the probability anymore, it's the expected frequency of u. So we still have 4, 5, 6, 7. But we're going to take each of those numbers and multiply them by 100. So you get 20, 30, 30, 20. Please notice that if you add all 4 of these, that these add to 100. C, find the mean of the values of u found in these 100 trials, assuming the frequencies of each outcome of u are given by your expected values in B. So, the way you find this mean is kind of similar to how we found a mean back in one of our stats units, where if there's 20 times that you get a 4 and 30 times that you get a 5, if we're going to find the mean, Then we would multiply each of those numbers. So 4 times 20 plus 5 times 30 plus 6 times 30 plus 7 times 20. And then we have to divide by how many there are, which we already know that there's 100 trials. So what this means is that 5.5 is the average. I mean, what are we calling it? Yeah, this is the mean. Part D, interpret your answer. Really, this just is that, 5.5 is a decimal. It's not a whole number. It's not part of 4, 5, 6, or 7. So, it's an expected value, I guess is what we're about to call it here in a minute. But yeah, so part D is that. So it's not possible to get a 5.5 in this problem, but it is the mean. The central value, I think, is what they're calling it. Now, before we get to example 20, sorry, I ran out of space. I need to move this for a second. We need to do a formula. So when we found the mean up here, when we took all these and multiplied them times their probability or the number of outcomes that happen for each of those, and then average them, you're essentially finding an expected value. The expected value is basically if you were to do whatever experiment you're doing 1,000,000 times or 10 billion times, what the average would eventually approach. So the expected value of capital X is this notation, e to the x, e of x. Now it equals the mean of the data, if you want to think of it like that way. So that's mu. So this is mean. But the way you find it is by summing all of the x's, which are x times the probability of x. Sorry, I forgot the notation. We use capital. So I realize that formula can look really scary, but I'm going to show you guys with this next example how it's really not that bad. If you're going to find, this problem is a newsagent in Oxford takes delivery of 6 copies of a Scottish newspaper each Sunday. The newspaper has a regular order from her customers for 3 newspapers. But sales vary according to current events and sports. The newsagent has collected data over the several years to help predict her sales. So, she usually prepares for 3 newspapers, but sometimes, 5% of the time she sells 2, 29% of the time she sells 4, 22% of the time she sells 5, and then she sells 6, 5% of the time. So these are probabilities in the bottom of that event happening, selling that many newspapers. To find the expected numbers of newspapers sold, and then we're going to interpret its meaning, the way you find the expected number so this whole thing is S. So the expected value of capital S is going to be the sigma of little s, capital P, capital S, little s. Now, that's confusing, but really all you have to do is take each of these and multiply them with each other and then add them all together. It's very similar to how we found a mean with our frequency tables back in first semester. So this is 2 times 0.05 plus 3 times 0.39 plus 4 times 0.29 plus 5 times 0.22 plus 6 times 0.05. If you crunch that all out, that means the expected value of S is 3.83. So what this means is that on average, she will sell 3.83 newspapers. So it's not possible to sell 3.83 newspapers. That's just the average if she were to sell newspapers from now until the end of time. Given those probabilities, she would usually sell about 3.83 newspapers. So what do we want to say? She probably will, she should prepare for 3, but probably closer to 4. The probability of her selling more than 3 newspapers would be all of these numbers added together, which is about 50%. But I think really the whole point of this problem is just to find the expected value, that the expected value is 3.83. If X is a discrete random variable that represents the gain of a player, then when the expected value is 0, this means that the game is a fair game. So if you go to Vegas or something like that, all of the games are not fair games. They're usually, if you play them long enough, the house gets more money because it's an unfair game. That would mean that the expected value is less than 0, which means that the house gets some of your money. If you design a game where the player wins more often than the house, that's an example of another unfair game where it's advantage towards the player. But if it's right down the middle, if the expected value is 0, that means that the house and the player have an equal chance of winning. It's like if you were to flip a coin and say, okay, heads I win, tails you win, the expected value would be 0 because you each have a probability of 1/2. All right, this problem. Some students have a meeting to design a dice game to raise funds for charity as part of their CAS project. Some of the decisions made in the meeting are lost. So they lost these 2 boxes right here. They don't know the probability for 4 or the probability for 6. This is prize money. They're raising charity. So this is how many dollars they're raising each time. At any rate, what we're going to do with this is determine the missing entries in the table and find the probability distribution. So part A. Oh, I cut off part of the problem. We need more information. They did say that they also recall that the expected value, which is crazy that they know the expected value, but they do, is 67 out of 20. Now that we know the expected value, we're going to find the missing entries. So we don't know what the missing entries are, so we're just going to call them A and B right now. I know that this whole row should add up to 1. So what that means is that 11/40 plus 1/4 plus A plus B plus 1/8 is equal to 1. If you subtract these 4 numbers from 1, that will tell you that A plus B equals 7/20. So if you do common denominators, but really you can just grab your calculator and do 1 minus those numbers and then hit answer to fraction. Now this right here is one equation with 2 unknowns, so this is not solvable. What we're going to do is try to find another equation based off this fact right here, that the expected value is 67/20. Remember, to find an expected value, you have to multiply each of the values times their probability and add them all together. So this becomes 1 times 11/20 plus 2 times 1/4 plus 4 times A plus 6 times B plus 7 times 1/8. Why did I switch up notation? And this whole thing has to equal the expected value, which is 67/20. Now, very similarly to that top problem, if you take these numbers and subtract them from 67/20, so they get the A and B by themselves, you get 4A plus 6B is equal to 17/10. Now, these two things together are a system of equations. It may have been a while since you've done a system of equations, so I'm going to help you remember how to solve this. To be able to solve the system, let's just start and say this is A plus B equals 7/20, and then 4A plus 6B is equal to 17/10. To be able to solve this, you could use substitution or elimination. I'm going to show you guys the elimination method. To be able to eliminate the A's, see how the bottom A is 4, but the top A is just a 1. I want the top A to be a -4, so then the 4A and the -4 would cancel each other out. So what we need to do is multiply this top times -4, but then also times this by -4. So when I rewrite that equation, it will be -4A minus 4B, and then let's see, 4 goes into 25 times, so I think that's -7/5. So now you can kind of ignore the top equation, and what's going to happen is we're just going to, because we changed the top equation to become the bottom one, we're going to add these two together. Because when we do that, the A's will eliminate. These go away. We get a 0 there. Then here we get 2B. And then 17/10 minus -7/5 is 31/10. Divide both sides by 2 to get the B by itself. That's 31/20. Why is that not what the book got? Oh, never mind. I made a mistake right here. I should have done 17/10 minus 7/5. There we go. I wasn't subtracting. I was adding them together, which is 3/10. And then divide by 2. We get 3/20. So we found B, but that's only half the battle. Now you need to take that B and plug it back into any of the OG equations. So if we take the top equation, which is A plus B equals 7/20, and replace B with 3/20, we get A plus 3/20 equals 7/20. Subtract 3/20 from both sides. 4/20 is 1/5. That means that if we were to redraw the distribution, which I think the original distribution was all, or no, they're just like that. Okay. Come on, Jolly. So now that we found those values, 1, 2, 3, 4, 6, or 1, 2, 4, 6, 7. And then it was prize money. And then the probability of each of them. And then it was 11/40, 1/4. And then we found that A was 1/5. Right here. And B was 3/20. And then the last one they gave us, which is 1/8. From there, we're supposed to find the expected value of all this. So if you take the expected value, remember that's each of these multiplied together and then added together. So it'll be 1 times 11 40ths plus 2 times 1/4 plus 4 times 1/5 plus 6 times 3/20ths plus 7 times 1/8. I believe this is 385. So what this means is when they're doing this game in this problem, that each person will probably get about 385 from the random game. So they need to charge at least 386 to make a profit. So even charging just 1 penny more would make them a very, very small profit. So it'd probably make more sense to charge like $4 or $5 for people to play the game. So that way, they still have a chance of winning money, but ultimately you will win if enough people play the game because you'll be making profit. All right, you guys, please ask me questions in class.